Okay, Bismillah ar-Rahman ar-Rahim. Now we'll continue doing this curve sketching section 4.6. If you notice, most of the questions that we did was about the graph the functions. But now we look at the old exam. These were just examples where we practice actually doing 4.3 and 4.4 for different functions, but we're doing it in one example. So we combine 4.3 and 4.4 and some old things about the break-in. Now go to the old questions. If you notice, most of them they are about the slant asymptote or the oblique asymptote. They call it oblique or slant. Okay. Now he said, which one of the following statements is true about this function? Okay, if you notice, they are talking about vertical, horizontal, and slant. Now the degree of numerator, if you call it G over H, just to understand it, degree of G is 3, and degree of H is 2. That means what? That means degree of G is greater than degree of H by 1. That means we have slant asymptote. Okay, I have one slant asymptote. Okay, and also that means we have no horizontal asymptote. No horizontal asymptote. So I have only one oblique or one slant. They call it oblique or slant. Huh? Now, concerning the vertical asymptotes, we have x squared minus 4 equals 0. So that implies x equal plus or minus 2, where this one is always cannot be 0. We cannot factor it. Huh? If you factor it, you have what? Yeah, it will not give you. We can factor it, but it will not. At 2, G at 2, or G at minus 2, both of them are not equal to 0. So we have vertical asymptote here. It will go to infinity. So we have non-zero over 0, which is will go to plus or minus infinity. It depends from right or left. But at the end, we have 2 vertical asymptotes. That's it. We want to find the slant asymptote of this function. If you notice, the degree here is 3 over 2. The degree here is half. So the difference is 1. So we'll do long division. 2x 3 over 2 plus 2x minus 3 over x to the power half plus 1. So divide this by this to get 2x. Multiply. I have 2x to the power 3 over 2 plus 2x. Now we just change the sign and we're getting minus 3. So I will stop now because this is degree 0 and this is degree half, so it's less than. So what is the slant asymptote? Y equal to x. That will be my slant asymptote. The tangent line to the curve is perpendicular to the slant asymptote. That means what? The slope of the tangent times the slope of the slant is equal to minus, since they are perpendicular to each other. Okay. Now, can I find the slant? Yes. Since this is the degree of the numerator is 2, the degree of the denominator is 1, so the difference is 1. So I can find the slant through the long division over x plus 1. That'll give me what? X times this, that will be x squared plus x. That will be plus, minus, minus. That will be x minus b. Divide, that will be plus 1. Multiply. You're getting what? X plus 1. All right? Yeah, you're getting x plus 1. So this is plus, minus, so we're getting minus b minus 1. So the degree now is less than this, so I'll stop. So what is the slant asymptote? Y equal x plus 1. What is the slope of the slant asymptote? It's only 1, the coefficient of x. Okay, now how to find the slope of the tangent? I know that the slope of the tangent will be f prime at, I have the tangent line at this point, at 0. Now, what is f of x? We can do f of x here. Quotient rule, derivative of the numerator. What is f prime at x? Let me do it here. F prime at x, that will be 2x plus 2 times x plus 1 minus derivative of the denominator, which is 1 times the numerator over this one square. So what will be f prime at 0? You can do it quickly. That will be 2 minus 0 plus 2 times 0 plus 1, which is 2 minus plus b over what? Over 1. So that will be 2 plus b. So I use this relation. This relation give me what? 2 plus b times 1 is equal to minus 1. So that implies 2 plus b equal minus 1. That implies b equal minus 3. And this is what I'm looking for. Okay, an equation of slant oblique with the oblique. Sometimes we call it slant, sometimes we call it oblique. They are the same. They have the same meaning. I need the long division. Degree, the difference is 1, so I need the long division. I'm getting 2x multiply. I'm getting minus 2x, correct? Plus 2x, sorry. 2x squared plus 2x. So that's plus, that's minus, that's minus. So I have this is cancelled. So I have minus 3x. Divide, you have minus 3. Multiply, I have minus 3x plus 1. Minus 3x minus 3. Plus, cancelled. 4 degrees less. خلاص. So I have slant asymptote y equal to x minus 3, which is this one. Same thing. Degree here 3, here 1. Long division. 2x cubed minus 3x squared plus 5 over x squared plus x. Divide, you have 2x. Multiply, 2x cubed plus 2x squared. Change sign. Minus 5x squared plus 5. Divide, you have minus 5. Multiply, minus 5x squared minus 5x plus 5. Minus 5x. Change, okay. Minus 5x squared minus 5x. Change signs. You have 5x plus 5. Degree is less than. This degree is 1. This degree is 2. So I stop. So it will be the slant asymptote y equal to x minus 5. That's it. Okay. Now this question, he said, which one of the following graphs represent this function? Okay. You can do it by trying to graph the function. You find the domain, find the intercept, find all the things related to that. Or you can do it by trying to get some information from that function and delete the one which does not satisfy this information. And for example, I notice if I do the long division, x, I have x squared, that's it, plus, minus, so I'm getting 1, so I have y equal x is a slant asymptote. This is my slant asymptote. Okay. Here, the y equal minus x, this is wrong. This is okay. This one wrong. This is okay, this is okay. So I am now between B, D, and E. What else I can do? Yes, I can take values. For example, f at 1 will be what? 1 plus 1, 2 over 1, that will be 2. Okay, f at 1 should be 2. But I know if I put it in the slant asymptote, I'm getting if x equal 1, then y equal 1 at the slant asymptote. That means my function is above the slant asymptote if x equal 1. Okay, look here, the slant asymptote is above the graph, so this is wrong. Here, the standard asymptote is above the graph, so this is wrong. At x equal 1, at n x equal 1, 1 should be a positive value somewhere here. Here, this is the only things remaining, so that is the only answer. Okay, you can do it by choosing other things, other values. Yeah, okay. If x is then the equation of the oblique, just I need to do long division. X cubed minus 2x squared plus 5 over x squared plus 3x plus 1. You notice most of the questions, they were just about the oblique or the slant asymptote. This is x cubed over x squared, that give me x. So I have x cubed plus 3x squared plus x is plus minus minus minus. So I'm getting minus 5x squared minus x plus 5. Divide this by this, getting minus 5, multiply minus 15x minus 5. Here's this give me 14x plus 10. I will stop. Degree is 1, degree here is 2. So I will stop. The standard asymptote y equal x minus 5. That's it. A function has one slant, so I need to check the vertical, horizontal, and slant. Very clear. The degree of the numerator is 3. The degree of the denominator is 2. So I have, for example, for sure, one slant, no horizontal. Asymptote. For the vertical, you need to, yes, I have these things x equal plus or minus 1, but I need to factor the y equal what? Because maybe there is some cancellation. I have x squared minus 6 minus 2 over x minus 1, x plus 1. And that give me x minus 2 times x plus 1 over this. So since this one cancelled, so I have a hole there. I don't have vertical asymptote. We have vertical asymptote only at x equal 1. So vertical asymptote only at x equal 1. So I have one slant and one vertical asymptote. Consider this function. Okay. Now he gave me a function. He gave me some information. He gave me y prime. He gave me y double prime. Okay. So he doesn't want me to waste time to find y prime and y double prime. And he asked me some information. Okay. Now, let me do, it seems we will do 4.3 and 4.4. We'll do it at the same. So the same graph with the same function. So let me see what will happen, because sometimes they ask about increasing, sometimes they ask about concave down, ask about all of these things. So he said, which one of the following is false? Okay, so what's the domain of F? All real numbers except 2. It doesn't ask you to graph, but he asks you some information where you need to do it through these steps for the graph. You don't need to do everything, but I need to do the things we did for 4.3 and 4.4. Okay, now for y prime, from y prime, I have this is point of discontinuity, okay, and y prime equals 0. That will give me what? X times x minus 4 equal to 0. So I have x equals 0 or x equal 4. So I'll combine these. I need to combine the point of discontinuity and this point. So I have 0. This is 2. This is 4. Check the sign. Check the sign of this one. The denominator is always non-negative or positive. It's x not equal to 2. So I'm concerned only about the numerator. So take a value before 0, minus 1. Minus 1, it will be, don't forget, y prime is x minus 4 over this. So minus 1 half negative times negative, that will be positive. And before 0, between 0 and 2, take 1. It will be 1 times negative. This one is always positive, so no care. I mean, we don't care about it. Between 2 and 4, take 3. It will be 3 times negative. That will be still negative. More than 4, it will be positive. Okay. So I have the things which is about increasing minus infinity to 0, correct, and 4 to infinity. So this is correct. And I have here relative minimum. And this is increasing. No. This is increasing, decreasing. So I have relative maximum, sorry. And this is decreasing, this is increasing. So I have relative minimum here. So I have relative maximum at x equals 0, relative minimum at x equals 4. Correct. Now, the other things is about, yeah, this is one also I can check and it's correct. When it says one slant and one vertical. And very clear. This is degrees 2, this is over 1. So I have slants and x equal 2 is a vertical. So this is also correct. Now we will deal with y double prime. If you notice, y double prime is what? There is nothing equal to 0. So I will check only the point of discontinuity. I will make the 2 here. Check before 2, take a negative value or 0. We're getting what? Negative. More than 2, take a value which is 3, will be positive. So it's concave down, it's concave up. So it's concave down minus infinity to 2, correct. Concave up to infinity. So this is correct also. Is there an inflection point? No inflection point. Because it's not defined at x equal to. The function is not defined at x equal to. So there is no inflection point. So this is my answer. The rest are true. One statement is false. This function, the same thing. Okay. One way to think about it is this function, absolute value of x, I know it's what? Is minus x if x is negative, x if x is greater than or equal to 0. So this function, f of x, will be minus x squared if x is negative, x squared if x greater than or equal to 0. Okay. Or I can check what? I can check this if x is an odd function. How can check it? I can check this one through, yeah, f of minus x equal minus x absolute value of minus x. So it's minus x absolute value of x. That will be minus f of x. So it's an odd function. This is true. They want the false statement. Okay. Now, the other things about increasing and decreasing. So let me check f prime. F prime will be what? Minus 2x if x is negative, 2x if x is positive. At 0, are they equal? Yes. At x equals 0, I have 0, and this is 0, so I can put the equality. Since it's there, I'll make it there. No, that will not make a difference. That means if prime at 0 exists and it's equal to 0, so this is correct. Okay, I'm looking for the wrong statement. Okay. Now, I know that if prime equals 0, that implies x equals 0. So, and it's there. Okay. If you plug it here, you have x equals 0, but 0 is not included. But here 0 is included. Okay, so I have 0. Before 0, take any value before, take minus 1, I'll substitute there, I'm getting positive. More than 0, I'm getting also positive, since I'm substituting here. So that means the function is increasing all the way in its domain. f(x) is increasing in its domain. Okay, since increasing in its domain, for sure it has no global maximum. It's increasing all the way. So from where there will come global maximum? Okay. There is no critical numbers, no, okay. Okay, the last thing is f of x is concave up in its domain. Let us find f double prime. F double prime will be what? Minus 2 if x is negative, 2 if x is positive, but at 0 f double prime does not exist. Okay, so when I do the number line, this is cannot be 0, it cannot be 0. So just when I do the test intervals, I have 0 because f double prime does not exist. So I have 0 and check before 0, I have negative, and then after 0, I have positive. So it's concave down, it's concave up. Is it concave up in its domain? No. So this is the wrong statement. And this is my statement that I'm looking for. So I'm looking for the false statement. Okay, the Snellius asymptote of this. Yeah, this is very easy. We know that this, as x goes to infinity, this goes to 0. So the Snellius asymptote right away will be y equal x as this goes to infinity. So I have y equal x. Very clear. One statement is false about this function. Okay. Here we don't have vertical asymptotes. This is correct. Also, we don't have slant asymptote because the degree, they are the same. Okay. Y equal 1 is a horizontal asymptote? Yes. Very clear. Horizontal asymptote. Y equal 1, same degree. So I have the leading coefficient with the leading coefficient, 1 over 1, which is 1. The x and y intercept are both 0, 0. Yes. Y intercept, I'll make x equal 0. I'm getting y equal 0. X-intercept, I will make y equal 0. I'm getting x equal 0. So this is also correct. So this is correct. So I have two things to check. Okay. Now y f x is decreasing over minus infinity and 0. I need to check f prime. What will be f prime? Will be 2x times x squared plus 1 minus 2x times x squared over x squared plus 1 squared. And that is what? That is 2x cubed minus 2x cubed مع السلامة 2x over x plus 1 square. So I have at 0, so I'll make the 0. Before 0, it's negative, and then it's positive. If x is decreasing over minus infinity to 0, this is correct. I have 0 is a local. This is decreasing, this is increasing. I have 0 is a local minimum. And if at 0, it's 0. There is no local maximum. And if you notice, this one, if you notice, always, if you make it g of x over h of x, always g of x less than h of x. Correct? So g of x over h of x cannot reach 1. It will not reach 1 for all the cases. So that implies in no. And it's g of h over h of x less than 1, since they are all positive. Less than 1, always less than 1, cannot reach 1. So this is my false statement because of this equality. Actually, the function is between 0 and 1, but cannot reach 1. Okay. It has a minimum at 0, it has no maximum, so cannot reach 1. Okay, so the range is this. If y equal x, ax plus b is the slant asymptote, and c is a vertical asymptote, find a times b times c. Okay, it means we need, well, a vertical asymptote is very clear, x equal half the vertical asymptote, where I notice in y, if I factor the numerator, I don't have 2x plus 2x minus 1, correct? This is x. I need, yeah. Let me do it in another way. Check if make this y equal f of x over g of x. So check if at half. Very clear it's positive. So it cannot be 0. So for sure x equal half. So I have an n0 over 0 at half. So I mean, as the limit as goes to half, so I have non-zero over 0, so it will be vertical asymptote. Either goes to infinity or minus infinity, it depends from right or left, who cares. But I have vertical asymptote. Now for slant asymptote, I will do the wrong division over this. I'm getting what? over this. I'm getting 3 over 2x. Multiply, that will be 3x squared plus 3 over 2x. Change the sign, minus, minus. So I have x minus 3 over 2, that will be minus half x plus 1. Am I right? 1 minus 3 over 2. It's minus half. Divide this by this, I'm getting minus 1 over 4. Minus 1 over 4. Multiply, I have minus half x plus 1 over 4. Change the signs. So I'm getting 3 over 4. That's it. So what is my standard asymptote? 2x minus 1. So I have A is 2, B minus, no. What do you mean 2x minus 1? My standard asymptote is what? 3 over 2, x minus 1 over 4. So A equals 3 over 2, and B equal minus 1 over 4, and C, which is the vertical asymptotes, x equal half, so C equal half. I want A, B, C. That will be 3 over 2 minus 1 over 4 times half. That give me what? Interesting. Did I do any mistake? X equal half. That's correct. That I divide this by this, I get 3 over 2, multiply, half 3x squared minus 3 over 2. Sorry. This is minus, so this is plus. Look at this. So this is plus 5 over 2. Be careful. Minus 3 over 8 is not there. So that will be what? This by this, I have plus 5 over 4. Multiply. Yeah, be careful with the calculations. Okay. That give me what? 5 over 2x minus 5 over 4. Or change the signs. That give me minus 1 over 4. So this one, sorry, it will be 3 over 2x plus 5 over 4. So I have this 5 over 4. Okay, so this is 5 over 4. So I'm getting what? 15 over 4 times 4, which is 16. Which is this? Yeah, you need to be careful with the calculation. Huh? This is the minus sign, make a big difference. Now I have this question where he gave me some information about the function y and y prime and y double prime, and he asked me to graph the function. Graph f of x. Okay, so no need to waste time to find f prime and f double prime. I need to, yeah, or like this one. Huh? Remember we did something similar here, where he gave me f prime, f and f prime and f double prime, and he asked you some information. In this question, he asked me to graph the function. Okay, let me try to graph the function. I have the domain is all real numbers except 2. I'm getting it from here. I have point of discontinuity at x equal to. Okay. Intercepts. I'll do the same, like what we did before. Y-intercept. X equals 0, I'm getting y equals 0. So I have 0, 0. X-intercept. I'm putting y equals 0. I'm getting what? I'm getting x, 2x minus 3 equals 0. So I have x equals 0 or x equals 3 over 2. So I have the points 0, 0, and 3 over 2 and 0. Okay, what else? Vertical asymptotes, very clear, x equal to. I have also slant asymptote. Yeah, how to find the slant asymptote? Long division. That will give you what? 2x. Multiply, you have 2x squared minus 4x. That plus minus, that will be plus. So it will be x divide plus 1. So I have x minus 2 plus minus, that's plus. It's 2. خلاص. So y equals slant asymptote y equal to x plus 1. Okay. What else? Symmetry, no symmetry. Okay, that's it. Now we'll go to f prime. F prime, it's ready. It's what? 2. This is x minus 3 times x minus 1 over this. Okay. Yeah, is x minus 3 times x minus 1. So I have 2 where the function is not defined. Also, I have 1 and I have 3. This is what I want to do. So I want to check now the sign for f prime. This is always positive. Who cares? So my concern is only the numerator. Take a value less than 1, take 0. I'm getting plus 1.5, 3 over 2. I'm getting plus times minus, that is minus. 2 and 3, 5 over 2. That will be negative, positive, negative. More than 3, that will be positive. So it's increasing, decreasing, decreasing, increasing. Well, I have local max here, and I have local min here. Okay. Now from f double prime, the only things I have, I'll make the 2. And that will give me what? Before 2 is negative and then positive. So concave down, this is concave up. Okay, take a value less than 2, 0, it will be negative, then that will be positive. Okay. If I put them in one graph or in one line, I have the 2. I have this is 1, this is 3. This is increasing, decreasing, decreasing, increasing. This is concave down, concave down, concave up, concave up. Okay, let me graph the function then. I'll graph the function. Let us see what will happen if I graph the function. Okay, as usual, we'll put the information. Asymptote, we have vertical asymptote at x equal to, very clear. Okay, I have 0, 0, this is a point. And 3 over 2, also this is another point here in the asymptotes. I have the slant asymptote, how to graph it. I will do values. If y equals 0, I have 1. Y equals 0, it's 1. And at x equal 1, it's 3. Y 0, it's 1. Y equal 1, it's 3. So something like this. So the slant asymptote will be something, this is 1. It will do something like this. And this is the function. You know what? Let me take it. Yeah. Yeah, let me take it here somewhere. Because I think I will do the graph up somewhere. That will give me like this. Okay. They have vertical asymptote here. And they have a slant asymptote here. Okay, slant asymptote. Yeah, it's a line. It should be like that. This is like that. Okay, so this is the slant asymptote. And they have 3 over 2 here and 0 here. Okay, by the way, the graph, will it cross the slant asymptote? We need to check. Y equal 2x squared minus 3x over x minus 2. Will it equal the slant asymptote, which is 2x plus 1? Do the multiplication. So I have 2x squared minus 3x equal what? 2x squared minus 4x plus 1 minus 3x minus 2. So I have 0 equal minus 2. So for sure the function will not cross or will not touch the slant asymptote, which is impossible. Okay. Now let me do the graph. Before one, the function is increasing, and what is it? Increasing بس concave down. Increasing concave down. So it will do something like this. It's increasing, but it will go beside this concave down up to 1. Well, what is f at 1? I can check f at 1. F at 1 is what? 2 minus 3, that is minus 1 over minus 1. That will be 1. So it will be somewhere here, up to here. Then it will decrease, but it's still concave down. Huh? So the function is concave down. And then it will decrease until here. Until 2, it will be asymptotes here. It will go like this. So it's concave down, increasing up to 1, and then it will decrease. Okay. Now, after 2, I had that, for example, at 3. What will happen at 3? Yeah, I can check f at 3. This is 1, huh? F at 3 will be what? 2 times 9, 18, minus 9, that will be 9. That will be 9. So it will be some value here. You notice at 2x plus 1, 3 is 7. So it's above it. So it will be some value here. Okay. And the function is doing what? Decreasing, but concave up. So it will do something like this. And then after that, this is 3. It will be, I have a local minimum at 3. Then it will be increasing and concave up. So it will do something like this. And it will go beside the asymptotes. Okay. This is 1. And this is 9. Okay. So is there an absolute maximum, absolute minimum? No absolute maximum, no absolute minimum. And the range of the function is what? From minus infinity to 1, union from 9 to infinity. That's it. Okay. You want you to find the absolute minimum and absolute maximum for this function. Okay, but I don't have, I have a continuous function, but not in a closed interval. How I can find the absolute maximum, absolute minimum? I need to graph the function, or just sketch a graph, or sketch the curve, make a sketch of this function. Okay, so let me do the things we usually are doing. What's the domain of f? All real numbers. X-intercept or y-intercept. I'm getting 1 over 3. Y equal 1 over 3. So I have 0 and 1 over 3. X-intercept, I'm getting what? Y equals 0, so x equal minus 1. So I have minus 1 and 0. Okay. What else? Symmetry, no symmetry. No asymptotes. I have horizontal asymptotes. Since the degree of the numerator is less than the degree of the denominator, y equals 0. That's it. Let me do f prime then. F prime would be what? X squared plus 3, derivative of the numerator, which is what? Minus 2x with the denominator. Minus x في numerator, the denominator times the numerator times this one, x squared plus 3 all square. That will be what? I have x squared minus 2x squared, that is minus x squared, minus 2x plus 3 over this. In other words, it's minus x squared plus 2x minus 3 over this. In other words, it's x plus 3 times x minus 1 over this. So f prime equals 0. I have x equal minus 3 or x equal 1. So I'll put these things. I have minus 3 distant intervals Before minus, you take a value minus 4, that will be negative, 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 that will be negative. Take a 0, it will be positive, negative, negative, that will be positive. Take 2, will be positive, positive, negative, that will be negative. So decreasing, increasing, decreasing. Okay. Now, to find the absolute maximum, absolute minimum, the convity will not change the what is the highest and what's the minimum of the function. So no need to go to f double prime. Just I will try to sketch the curve using this information now. Then I can get what is the absolute maximum, absolute minimum from the graph. Okay. So now I have 0 and 1 over 3. That will be 1 over 3 somewhere here. Okay. I have minus 1 and 0. That is minus 1 and 0. I have horizontal asymptote x-axis. Okay. And f of minus 3 is what? Maybe that will help me. F of minus 3 will be what? Minus 2 over what? Yeah, 12, which is minus 1 over 6. So at minus 3, that's also one of the points which I need. That will be minus 1 over 6 somewhere here. That will be minus 1 over 6. So I have this point here. Okay. And f at 1, let me do f at 1 right away. That will be 2 over 4, which is half. So if at 1, I have half. Half is here somewhere. That would be, which is more than 1 over 3 for sure. Okay, now let me to sketch the curve. No asymptotes. It's decreasing from minus infinity to minus 3. It's a decreasing function. Okay. How to graph this? Decreasing from minus infinity up to minus 3. Up to this point. It's decreasing. And I have the asymptote. This is the asymptote. So it will do something like this. Decrease. I know it's going concave up, concave down. Who cares? Just I need to find the value. Then it will increase until 1. It will increase like this, passing with all of these points. Increase. Concave up, it's going like this or like this. Who cares? I need just to find the absolute minimum, absolute max. So I don't care about this. You can find if they were trying to do it, it's up to you. Then it will be decreasing and go beside the asymptotes. Okay, so very clear. I have an absolute minimum here from the graph, and I have an absolute maximum here. So what is the absolute maximum? Half. And what is the absolute minimum? Minus 1 over 6. So I need capital M or small m plus capital M. That give me what? Minus 1 over 6 plus half. That give me minus 1 over 6 plus 3 over 6, 2 over 6. That will be 1 over 3, which is this one. So I use the graph to find the absolute maximum, absolute minimum. Consider this function which the following statement is false. Okay. And the false statement. If you look, he's talking about increasing local minimum, local maximum. No asymptotes for sure, no asymptotes because the function is defined everywhere. So just I need to care about f prime. Okay, now let us do f prime. Yeah, let us do f prime. I'm getting what? I'm getting 2 over 3 x squared minus 4 to the power minus 1 over 3. He wants the false statement, times 2x. So that gives me 4x over 3 x squared minus 4 to the power 1 over 3. Okay, critical numbers. What are the critical numbers? By the way, the domain is already now. No restriction. I have f prime equals 0, that implies x equals 0, and if prime does not exist, that implies x equal plus or minus 2. Very clear. Okay, so I put it in one. That will be minus 2, 0, 2. Take a value less than minus 2, take minus 3, it will be negative. Here you have positive, that will be negative. Minus 1, it will be negative. Over negative, that will be positive. Take 1, it will be positive. Over negative, that will be negative. Take 3, positive over positive, that will be positive. So it's decreasing, increasing, decreasing, increasing. I have local minimum here. I have local max here. And I have local minimum here. Okay. Okay. Now, let me check. Statement is the true statement. I will just cancel it. If it's increasing in this interval, minus 2 to 0, yes. 2 to infinity, correct. Decreasing, minus infinity, minus 2, and 0 to 2. So this is correct statement. I will leave this one. If has a local minimum at x equal 2, x equal minus 2, this is correct. And local maximum at x equal 0, this is correct. If has local maximum, he just reverse it. Local maximum at x equal and local minimum, this is wrong. For sure, this is my statement. Okay. If has an absolute minimum, but no absolute maximum. Okay, how to check this? I can sketch the graph of the function. Very clear, this is the one I'm looking for. But if I sketch the graph of the function, if I try to sketch the graph of the function, what are the asymptotes? Not the asymptote, the intercept. I have cube root of 16 at x equals 0. I have cube root of 16, which is somewhere here. Okay. Cube root of 16. When x equals 0, I have minus 2. When y equals 0, I have minus 2 and 2. Okay. These are the intercepts. My concern is about f of minus 2. That will be 0, the value of the function. And if at 2, the value of the function is 0. And if at 0, this. Okay. So it will be decreasing because I'm talking about absolute maximum, so I don't care about concave up, concave down. There is no asymptotes. So before minus 2, take a value, minus 3, it will be a positive value. So it will be decreasing. Maybe concave up, concave down, who cares? Then it will reach this. Then it will increase until 0. It will increase until 0. Then it will decrease until 2. Decrease until 2. Then it will increase again. So very clear. I know it will do this or this. Who cares? Huh? So very clear. I have absolute minimum, but no absolute maximum. So this is correct. So the only wrong statement is A. If this is the function, we need to find the slant asymptote. Degree is less by 1, so I can find the slant asymptote. I have what? Long division. This by this, I have 2x, multiply 2x cubed plus 2x. Is it? Okay. Yeah. This is 2x squared. Sorry. This is 2x cubed plus 2x squared. So this is plus, minus, minus. So I have minus 2x squared minus 3x plus 5. Divide, I'm getting minus 2. Multiply. That would be plus, plus. That would be minus 6 plus 5. So for sure, my slant asymptote 2x minus 2, which is this one. Okay. This one. This one, I don't think we can do it easily. Has no vertical asymptotes? Yes. Why this is true? Because I know that the limits, my potential vertical asymptote x equals 0, but I know this is equal to 1, special limits. So this is, he want the false, huh? This is true. Y equals 0 is a horizontal asymptote. Yes, if we do limit x goes to plus or minus infinity, plus infinity, let me do it, plus infinity. So I'm getting sine x over x, which I can do using, if I, yeah, I can do it by the squeeze theorem. I know sine x is between -1 and 1. So sine x over x is between -1 over x and 1 over x. This goes to 0 as x goes to infinity. And this goes to 0. So for sure, this goes to 0 by sandwich theorem or squeeze theorem. So I have y equals 0 is a horizontal asymptote. Is a horizontal asymptote. The same thing as it goes to minus infinity. If it goes to 0 equal to 1, correct. If x is an even function, yes. F of minus x will be minus sine x over minus x, which is sine x, so it's f of x. So this is true. And that's the only one remaining, and this will be the wrong one. And actually, the graph of the function is this one, where it's not defined at 1, and to do something like this. Yeah, just a sketch of the graph. So for sure, the maximum value is 1. No, it will not reach 1. Because if you notice, when I have a maximum value, yeah, sine x is always to -1 and 1. So if sine is 1 to be maximum, x will be pi over 2. So you cannot reach the 1. Yeah, you cannot reach the 1. So this is my wrong statement. The range of this function, yeah, the range of this function, I need to do it by graphing the function. Okay. I try to do these 3 problems, and then I will stop before I go to the questions from the book. Okay. Okay. Now the range, the domain of the function, all real numbers, which is very clear from here. This cannot be 0. Huh? This cannot be 0. No way that will reach 0. Since sine, the smallest value is -1. So the domain all real numbers. Okay. Okay. Actually, to find the range, what I will do, I will find the absolute maximum and the absolute minimum. That will give me the range. For sure, the range will be here, the absolute minimum, call it M, and this is capital M. So I have M to capital M. That will be the range of the function. If I get the absolute maximum, absolute minimum, for sure it will be, the function will be bounded between these two. And for sure there's an absolute maximum, absolute minimum from the solutions. All of them is closed. Okay. Now I notice also, what is the y-intercept? Or before that, the function is a periodic function. So I notice f of x plus 2 pi will be what? Cosine x plus 2 pi over 2 plus sine x plus 2 pi. That will be cosine x over 2 plus sine x, which is f of x. So it's periodic function with period 2 pi. Okay, that means what? So instead of doing the function over r, I will do it only over this interval between 0 and 2 pi, because the rest is just a copy of it. So I need to check the function over this interval. There are 2 ways to solve it. One way is to try to graph the function. So I can have the absolute maximum, absolute minimum, so that we get it. Another way, This is a continuous function over a closed interval, so you can do 4.1, section 4.1 idea. But I'll find the critical numbers, find f at the endpoints, and at the critical numbers, the maximum will be the absolute maximum. The largest will be the absolute maximum, and the smallest will be the absolute minimum. Let me do it this way, because I think in the class I did it the other way, where I graph the function. Okay, so now, look, I cannot do the same here, because this is not a periodic, so there is no closed interval. I cannot do it I cannot do it in this example, but I can do it in this one. Okay, since I can make the function over that, and since it's a copy, for sure, if I have absolute maximum over this interval, then I have absolute maximum over R. Okay, and the same thing for the absolute minimum. So we'll do f prime. F prime will be what? Minus sine x times the denominator minus cosine x over this. So I'm getting what? Minus 2 sine x minus sine squared minus cosine squared, that is minus 1 over this. To find the critical numbers, I have this equal to 0. So I have sine x equal what? Minus half. When sine x equal minus half, I have x equal 7 pi over 6 and 11 pi over 6. Okay, so I will check now f of 7 pi over 6. That give me what? Cosine 7 pi over 6, which is third quadrant. That will be minus square root 3 over 2 minus half. That will be minus square root 3 over 2. 2 minus half, that will be 3 over 2. That give me minus square root 3 over 3. Okay. F 11 pi over 6. Cosine 11 pi over 6 is what? Square root 3 over 2 minus half. Still sign the fourth quadrant is negative. That gives me square root 3 over 3. F at 0, that will be half. F of 2 pi, that give me what? Cosine 2 pi 0, 1. It will be half also. Okay, so very clear, minus square root 3 over 3 is less than half. This is negative, this is positive. So this is my absolute minimum. So this is for sure absolute minimum. By the way, this is the only answer. Okay. Now I want to check which one bigger, half or square root 3 over 3. Which one is bigger? Let me multiply by 3. Multiply this by 3. So I have 3 over 6. Multiply this by 2. I have 2 square root of 3 over 6. For sure, this one is less than this. Square root of 3 is around 1.7. So this is 3.4. So for sure this is greater than this. So this is will be less than. So this is will be my absolute maximum. So this is my absolute maximum. So my interval is this, the range is this one. As I said, you can do it by graph the function, but maybe this one is easier. Okay, global minimum of this, also the same idea. You need to do it by graphing the function. I have, this is the domain. Here is different from 0 to infinity. Okay, I don't have a closed interval, so I need to do it by graphing. How to do it? We'll do intercepts, x-intercepts, y-intercept. Actually, we start easier. Implies x equals 0, that y equals 0. X-intercept, I will make y equals 0. So I have x equals 0 or x equals 3. So I have the point 0, 0, and 3 and 0. Okay. Symmetry, no symmetry, no asymptotes. So we'll go to the derivative, f prime. Or let me rewrite f as x to the power 3 over 2 minus 3x to the power. That will make it easier to do the calculation. F prime will be what? 3 over 2 x to the power half minus 3 over 2 x to the power minus half. So I have 3 over 2 x is minus half. I have x minus 1, which is 3x minus 1 over 2x to the power half, square root of x. Okay. So that f prime equals 0 implies x equal 1. F prime does not exist, x equals 0, which is the end point, so no need to be bothered. This is 0, this is 1. Take a value between 0 and 1, half will be negative, that will be negative, positive, so it will be decreasing, increasing. And actually we'll deal with it in 4.7. If there is only one change, then for sure the local will be absolute. But let me graph the function since I'm done. This is will give me what? 0, 0, 3, 0. Yes. Okay. And the function actually is only from 0 here, huh? I have nothing here in the negative side. So 0 and 1 is decreasing. Take the f at 1. F at 1 will be what? F at 1 will be minus 2. So it's negative. At 1, it's minus 2. Somewhere here. So it's decreasing from here. It decreases. Concave up, concave down, I don't care. That will not make a difference for me to find the absolute maximum, absolute minimum. And then it will increase, and then we'll pass through this. So for sure, I have an absolute minimum here at 1 and minus 2. So this is 1. So this is the point. Okay, let me finish by this question. I want the slant asymptote, and he want what? He want a. Notice this is x squared minus 3x. Minus 3x squared. I have x cubed minus 3. No. A equal 1 and B equal 0. So plus B will be 1, which is this one. I'll stop here. As if we did. Yeah, if you notice, most of the problems is about the slant asymptote, except some problems he will ask you some information about the function. This is the closed interval. Maybe it's just an idea to graph the function. Other than that, most of the problems about the slant asymptote.